The topic is insertion sort. This is one of the important sorting technique. For understanding insertion sort, we must understand why the name insert is taken. So insertion means what? If we understand that, then the sorting becomes very easy, and the same idea is followed by insertion sort algorithm. So let us understand what does it mean by insertion here. So for understanding insertion, I have taken an array, a list of elements, and these elements are already sorted. And in this list, I want to insert 12 in a sorted position. So it should be inserted at a place where it should come in the sorted order. So here insertion means inserting an element in a sorted array at a sorted position. So it should be inserted at sorted position. Let us see how we can insert this element in a sorted position in an array. Now listen carefully. Where this 12 should come? So after 2, after 6, after 10, before 15. It should come here. 12 should come here. Then insert 12 here. For inserting 12 here, what I have to do? I have to shift all these elements on the right hand side. Make a free space here, then insert 12. So if you observe what I have done, I first found out where 12 should come. Then I said I'll be shifting the elements. So the important thing is you don't have to find out where it should come. Directly you can start shifting the elements. You don't have to find its position. Now I will show you exact procedure how this insertion should work. Let us start. I want to insert 12. The last element is at this index. I don't have indices. Okay, I will write down indices. Last element is at index 6. So is it greater than 12? Yes, shift it. Move to the next element. 25 is greater than 12. Shift it. And next element, 20 is greater than 12. Shift it. Next element, 15 is greater than 12. Shift it. Then 10 is not greater than 12. So I am here now, right now. Okay, I have moved all the elements. Now right now here 10 is not greater than 12. So this place is free. So this place store the element 12. So all these elements will be shifted and 12 will be inserted here. So I don't have to search and find out its position. From the last, go on shifting larger elements. Then wherever you get any element smaller than the element that you are inserting, insert the element there. So all the larger elements are shifted on right hand side. That's all. This is insertion. Then let us also see insertion in a linked list. So I have taken a linear singly linked list, and this is a list of sorted elements, and I want to insert 18. In a linked list, we don't have to shift the elements. Shifting is not required. Then we have to find out where this 18 should come. Like in this linked list, 18 should come after 15 or before 20. So I should find out its position and insert it. That's all. So for finding its position, I will take a pointer to traverse a linked list. Then also I will take one tail pointer. Now I am showing you the procedure how to insert it. Check P's data, that is smaller than this one. So move P to next, but before that bring Q upon P and then move P. This is smaller than 18. So again move P. But first bring Q upon P, then move P. Now P's data is smaller than 18. Then again move P and Q. So first Q, then move P. This is still smaller. 15 is smaller than 18. So move Q upon P and move P to next. Now 20 is greater than 18. So we have found the first element which is greater than the key element that we are inserting. So we found its position. So it should be after Q. So for that, take one more temporary pointer and create a new node. Insert this value 18. Then make this T's next point on P and Q's next point on T. That's all. This is inserted. Now if I start from here, 2 to 6, 6 to 10, 10 to 15, 15 to 18, 18 to 20. So 18 is inserted in a sorted position. So in a linked list, we have to find out its position and then insert. Whereas in an array, we don't have to find the position. Simply shift the elements, and once you get a smaller element, then insert. And once you have finished shifting all larger elements, then insert at a free space. So what is the time taken for insertion in an array? Shifting of elements. How many elements? Some elements are shifted. So n. Depends on the number of elements. Maybe 0 elements are shifted, maybe all elements are shifted. So it may be minimum constant, maximum n. Minimum constant and maximum n. Then here, find out the position using P and Q. So traversing takes time. Insertion takes constant time. Just we have to create a node and make links. So searching for a position takes time. How much time it takes? It will traverse a few elements. So let us say n. So it may either traverse all n elements or just one element. So it may be inserted before 2 also, right? So time may be minimum constant, maximum n. So inserting an element in a sorted list takes minimum constant time, maximum order of n time. So that's all. I have explained you what does it mean by insertion. Now I will explain you insertion sort. That will be very easy for understanding.